Hello, dear student. Welcome to Polp Mathematics 11. This is module 3 that we will be busy with this today. In this session, what we are going to do is we are going to look into, assignment and exam issues. How to approach or how to deal with questions and assignment activities that you will be given in assignment as well as in exams. Okay, my name is Noah Kausep, and I am the tutor for this module. Okay, now it is expected from you in this module to be able to do the following. You should be able to do calculations that deals with negative numbers, positive numbers, fractions, decimals, ratios, and proportions, and also be able to estimate. Those are the things that you are supposed to do. You should also be able to make use of your calculator. You need to really familiarize yourself with your calculator. It's no use borrowing a calculator when you go to exams and you don't know the functionality of that calculator. You will struggle. So familiarize yourself with your calculator, because it is going to be very, very important tool that you will need in this module. Furthermore, you should also be able to do calculations that deals with equations, as well as you should also be able to calculate things that deals with indices. Furthermore, you must also be able to use or convert units correctly, and you should also be able to draw graphs, especially a linear graph, and also curve graphs. And lastly, you should also be able to do calculations that deals with circle, and also with angles, and also with triangles, especially the similarity concept, which is really useful in applying indirect measurements. So let's get started. Let's look into positive, negative, and decimal numbers. What do you need to do in this area, in this section? Under numbers, students are required to operate at math level 6. That is mathematically skilled to do, as I've already mentioned, certain things like to calculations with positive and negative numbers, do calculations on a calculator, and be able to also estimate. Let me just give you an example here, because estimation is a very useful concept when it comes to mathematics. For example, if I give you a numbers, a multiplication problem, 9.6 times 4.4. Now, before you run to a calculator, our heads, our minds can work out these things very fast. But an estimate of an accurate number, if you have a sense of the outcome of the number when you do it on a calculator, then you are assured that that number that you are getting is accurate. Okay, at least you have a sense that that number is not way off. For example, 9.6 is approximately 10. So in your head already, you have a 10 times 4.4, which is 4. You can just say 10 times 4, which is 40. So the number that you must get on your calculator must be roughly around 40. Okay? If it's close to 40, well and good. But if you are way off when you are doing a calculation, then you must know that you have made an error on your calculator. That is why estimations are very important. Now, when we calculate it, when we use a calculator, as you can see, it gives us 42.24, which is close to 40. But in your head, you can quickly do estimations. Okay. Secondly, the second concept that we need to look into is Bodmas. Not all calculators operate on Bodmas principles. Okay, for example, a 4-function calculator does not operate on Bodmas principles. What is Bodmas? It's just an order in which we do calculations. If you are given a complicated addition problem or calculation problem, what you need to do is you will first deal with brackets. If there is a bracket, you need to get rid of the bracket. It means you have to expand. Okay, remove the brackets by expansion. Okay, and then after you have done it, you can look into off. That means, for example, something off. So you deal with those calculations, because off is just another way of multiplication. So you look into off, and then furthermore you look into division and multiplication. It doesn't matter which one comes, which operation comes first normally with multiplication and division. So you first do division and then multiplication, or it can be other way around also, it doesn't matter. And then finally you deal with addition and subtraction. Okay, so that is the order in which we do things. Now if we look at this simple problem that we have here, that we need to simplify, 60 minus 34 times 2 plus 21 divided by 3. If you start doing the calculations from the left to the right, ignoring the Bodmas principle, you can have different answers. Okay, for example, you might have negative 246. That might be the answer that you will get. But if you follow the order, then you will first start with division. So that means 21 divided by 3 will give us a 7 there. And then we look into multiplication. You have negative 34 times 2, that will give us negative 48. And then finally we are dealing with additions and subtraction. So that means you have 60 minus 68, which gives us negative 8, plus a 7 will give us negative 1. That's what we have. That is actually the answer that we are looking for, negative 1. But if we approach it in different ways, we can have different answers. As you can see there, we have different answers that we are getting. With the second example, the same thing. You must first do division, or the brackets first. After the brackets, you can do division, and then you can do multiplication. But you can interchange multiplication and division. You can first do multiplication and division last. It will not be a problem. Okay, you will get the correct answer, which is 9 in that case. So lastly, we look at Bodmas. Bodmas now is an agreement or a convention that we have in which order we need to do operations. So normally a scientific calculator is already programmed in such a way that it does Bodmas. Okay, so you can just press in the things on a scientific calculator and it will just operate following the Bodmas principle. But other calculators, like a 4-function calculator, which normally accountants use and so on, that does not operate on a Bodmas principle. So you have to be careful in which order you do calculations. With the powers of numbers, what I want you to pay attention is the misconception that normally students have when it comes to powers. So indices, if you look at the indices, 2 cubed or 2 to the power of 3 does not mean 2 times 3. It does not mean that. It means 2 times 2 times 2, which gives you 8. Whereas 2 times 3 gives you 6. So you need to differentiate, because mathematics is a language. So you need to understand the language. What we mean by indices, you need to understand it. Let's continue. A scientific notation. When we look into a scientific notation, it is just a way of expressing numbers that are too large or too small in a decimal form. So we write it in a decimal form, numbers that are too small or too large. For example, we have an example here, 4,100. Yes, that number. We can express it even if it's not a very large number. We can still express it in a scientific notation. So that means we have to write it in such a way that the decimal part of that number is between 1 and 10. It can be 1, but it cannot be greater than 10. It cannot be 10. It must be less than 10. So when we express that number, it gives us 4.1 times 10 to the power of 3. Okay, so that means 4.1 is between 1 and 10. Okay, we can also look at the second example. It's a very small number. So the first part, the decimal part, we must express it in such a way that it is between 1 and 10. Okay, so it cannot be 13.2, or it cannot be 132, or it cannot be 0.1 something. It must be a number that is between 1 and 10. So times. So normally what happens is the reality is given there as an example. I'm not going to go into it now, but normally the shortcut that we have is by we tell the students normally to what? Move the comma certain places until the decimal number that you have must be between 1 and 0. So in the first example, we move the comma to the left 3 places, so that the decimal number that we are getting is between 1 and 10. So it's 4.1. So that movement of the comma is the one that gives us the power, 10 to the power of 3. And in the second one, we move the comma to the right, 1, 2, 3, 4, 5 places. But because it is a small number, that's why the power becomes negative 5. If we move it to the right, the power becomes negative. If we move it to the left, the power becomes positive. Okay. The scientific calculator. You need to, as I have already mentioned, be familiar with your scientific calculator. As human beings, we are actually problem solvers. As the years have passed, we have come up with tools that can do the things very fast at the speed of light. It can calculate things so that it leaves for us room to solve problems. Years pass, long division, we used to do long division. How to divide numbers. It was a long division, and we still teach it at schools, but we necessarily don't have to learn how to do long division now. Why? Because it can be done by a calculator. So the donkey work, we leave it to a calculator to do it, so that we solve problems. Let's look at that example. 31 divided by 18. What is that actually? This is a problem. We can put it in words. If you have, let's say, 18 learners or children, and you have bars of chocolate, 31 bars of chocolate. They are all equal length, and then you have to divide those bars among among 18 children. How are you going to do it so that it is fair? That is the problem that you are sitting with. So what do? You take the calculator, punch in the numbers, okay, and then you have fractions also that you need to deal with. All right. So if I punch it into my calculator, 31 divided by 18, it gives me, what did I do? 31 divided by 18 gives me, let me just take it to decimal, 1.72. 1.72. So that means each learner is going to get one piece and more or less 7 pieces out of 10. Okay? So that's what each learner is going to get roughly. Okay? So for them to, for it to be fair, that is what they are going to get. So basically what the calculator do, what it does is it simplifies calculations for us so that we can solve problems. Percentages, ratios, fractions, and so on. If we look into it, the key idea in this section is that the students need to convert from one form into another one, okay? They should be able to convert from fractions to decimals, from decimals to percentages, and so on, okay? For example, we have an example there. From percentages, we can convert it to fractions and to decimals and vice versa, okay? So what is percentage? Percentage is just out of 100. If you say 30%, what does it mean? It means 30 out of 100. If it's 30 out of 100, you already have a fraction, 30 over 100. So what do you do with that? You can simplify it, and then you have a simplified fraction, which is 3 over 10. You can also convert it to decimals, which is 0.3. Okay, that's what we have. The second key concept is equivalence. Okay. Now, equivalence, we apply equivalence to compare fractions. You will find that in the assignments as well as in the exam, normally you will have questions where you have to arrange fractions and numbers, these are whole numbers, whatever. You have to be able to arrange them maybe from the least to the greatest, okay? Or ascending order or descending order, you have to arrange numbers. So for you to arrange numbers in such a way, you need to know equivalence, okay? All right? One way that we can do is by making use of equivalence strips, okay? So which are the same length. And the first one, in this case, you divide it in 8 pieces, and you have 5 pieces out of the 8. The green pieces are 5 out of the 8 pieces. The second one is 3/4. So you divide the strip into 4 equal parts, and then 3 are colored in out of 4. And the last one, you have it 1/2. So 1/2 is colored in. Then if you compare there, you can immediately see that 3/4, that's the biggest number, and then followed by 5/8, and then 1/2 is the least in this case, okay? That's what you can do. Second way of doing it is by looking into equivalent fractions, okay? I can just give you, and we can do it here by making use of the lowest common multiple. You have 3/4, you have 1/2, okay, and you have 5/8, okay. This one, because you want to take the denominator to 8, so if you multiply here by 2 and also on top by 2, what you have, it's 6/8, okay. So 3/4 is just the same as 6/8. 1/2, you can multiply here by 4 and also here by 4. So that means you have 4/8. 4/8. 1/2 is just the same as 4/8. Okay? And this one, you don't have to do anything here. Now, if you compare these numbers, you can see that here you have 6/8, 4/8 here, and 5/8. So this is why this number is bigger, and then followed by this one, and then the smallest one is 1/2. Okay? So that's another way that we can do it. Also, even in the exam or in the assignment, you can convert these fractions into decimals. Okay? 3/4 is what? 3/4 is 0.75. Okay? What about 1/2? 1/2 is 0.5. What about 5/8? 5/8, what does it give you? 5 divided by 8, okay, 0.625, okay? Now you can compare the 10th place, okay? You can look at the 10th place. This one is bigger, 0.7, and this one follows 0.625, and then this one is the least or the smallest number. So when you convert it to decimals, you can easily tell which number is the least and which one is the greatest. And that way you come back now to the original numbers that you are given and you arrange them. So the smallest number will be 1/2, and then it is followed by 5/8, and then the last one, the biggest one, is 3/4. So you are going to arrange them according to the instructions that you are given. You are going to go by doing it. Okay? So that is that. In terms of fractions, we compare fractions in order for them to arrange. Okay? Operations on fractions is not difficult, especially in these days where we have calculators that can do the things as it is. As the way we write it, the calculators can also do the things. We can also punch in numbers just the way we are writing. So therefore, doing calculations, dealing with fractions is not difficult. For example, the number that we have, if you don't have a calculator that does not deal with fractions, then what you need to do is put the denominator into brackets. So what you have there, 32 divided by 3 plus 5, okay? What you need to do is put this in brackets, okay? So that you don't create errors, okay? All right? Or you can already calculate this one in your head, because it's simple in this case, which is just 8. 3 plus 5 is just 8, okay? But what students do when they do calculations is they will say 32 divided by 3 plus 5, and they will get a wrong answer, okay? Okay? Because if you do that on your calculator, you can get something which is different, because 32 divided by 8 is 4. Okay, you are supposed to get a 4. All right, but now if you take 32 and you say divided by 3 plus 5, you are getting something totally different, which is 47 divided over 3. 47 over 3. That's what you are getting, which is the wrong answer. Okay, that's why you need to put things in brackets so that the calculator is not confused in terms of the order in which the calculations are done. Okay, that's simply one thing that you need to be careful about when you do calculations. All right. Okay, equations, indices, units. A good number of marks in assignments and exams come from this section. Okay, a very good number of them come from here. So you need to be able to really know how to simplify, how to solve equations, how to do substitutions, how to rearrange, okay, equations. You need to really pay attention to those things, because a very good number of marks come from there. In your module, you have a lot of examples of this, so I will not spend time here going through this one by one. Okay, I'm just letting you pay attention to this section, because a good number of marks are coming from this area. Okay, let's just continue. Proportion. When we look at proportions, this is the section where students struggle the most. Okay, and when we deal with proportions, they are all over the sections, because it can be applied in converting units, it can be applied in measurements, it can be applied in problem solving. It's applied where we are dealing with direct proportions and indirect proportions. Okay, so it's all over all the sections. Actually, proportions we are dealing with it in all the sections in your module. So therefore, you really need to master proportions. Really pay attention to proportions. Okay, it's not really difficult. We are going to quickly look into it now. Let's just look at examples. Okay, when it comes to direct proportions, we have an example here. Let's look at the example. A recipe requires 3 eggs to make 7 biscuits. How many eggs will be needed to make 28 biscuits? Okay, 28. Now for 7 you need 3 eggs. For 28, how many eggs are you going to need? Now you sit down and you look at that problem. As one quantity increase, the other quantity must also increase. Okay? So that is the argument that you must make. If x, 3x, for 7 biscuits you need 3 eggs. So now for 28 biscuits, you will need more eggs. Okay? So that means as this one increase, the other one must also increase. So that is a direct proportion that we are dealing with. So if it's a direct proportion, how do we deal with it? Now there are 2 ways that we normally do these things. Okay? 2 ways in which we are doing. Either you come up with the formula, or you use cross multiplication. Okay, cross multiplication is actually the fastest, faster way when it comes to direct proportion. But when it comes to now indirect proportion, you need to know how to deal with it. Okay, all right. So let's look at this example. Okay, so now I can look at it. I have 2 things here. The first one is biscuits. And the second one is, what did I write here now? G. I don't know what G stands for. I was supposed to write X there, probably. Okay? Now, but it doesn't matter. Let G stands for X and B for biscuits. Now, these two things are directly proportional. Okay? That means if B increase, the number of X must also increase. So therefore, we use this symbol in order to tell us that they are directly proportional. Okay? Now, if they are directly proportional, there must be a constant for us to equate these two things, to put them equally. There must be a certain ratio that will make these two things equal. Therefore, we are saying B is equal to a certain number times G. Okay? Because they are directly proportional. Okay? Now, we must find K. We want to find K, that ratio. Okay, we need to find it. So how do we find it? We are given, for 3 eggs, we have 7 biscuits. So we can make use of that. We can now substitute in the formula. In the place of biscuits, we have 7. We don't know our K. And in the place of X, we have 3 times 3. Okay? Now, we can make K the subject of the formula. So we can divide both sides by 3. So we have 7 over 3. So that is our constant. So we must now go back and replace this constant into our equation. Okay? So if we replace it in our equation, we have 7 over 3 G. Okay? So that what we have here is now our formula. We have a formula now. Now we can apply this formula. We can use this formula for any quantities that we want. Okay? Now if we have 28 biscuits that we want to calculate, that we want to bake, we can plug it into the formula. All right? So biscuits, X. So if we have 28, let me not waste paper. We can just do it here. 28 biscuits. Our constant is 3. And G is what we do not know. Okay? All right? So now we want to find G. So our G, we can just swap the equations, is if we divide by a fraction, we can invert and multiply. You know about it. So it's 28 times 3 over 7. Okay? Which gives us the answer that we have already. There is 12. Okay? Because 7 goes there, 1. 7 goes there, 4. 4 times 3 gives us 12. Okay? So we are getting a 12. So that's one way of doing it. Finding the formula. If you have the formula, then you can plug into the formula in order to solve it. Direct proportion. Okay? Let's look at cross multiplication. We can use another method, cross multiplication. Okay? Direct proportion, since we are dealing with direct proportion, for 3, I don't know, X, okay? What do we have? We have 7 biscuits, okay? Now for 28 biscuits, okay? What will be our X? So X, we don't know that one. All right. So now in this case, what we do is just to cross multiply, okay? Cross multiply. right? So x times 7x, that will be equal to 3 times 28, okay? So is 3 times 28, okay? And now, in order to find x, we must get rid of this coefficient in front. So we divide both sides by 7. So x is equal to 3 times 28 over 7, which we have already here. 7 goes there 1, 7 goes there 4. 4 times 3 is 12. Okay. So whichever way you are following, you should be able to get the same answer, okay? But creating a formula is also very useful, okay? So that is now direct proportion. Let's go into indirect proportion. Almost the same thing that we will use there, okay? We have a problem here. A journey takes 15 minutes when traveling at 80 kilometers per hour. Okay, how long would the same journey take when traveling at 120 kilometers per hour? Okay, 15 minutes if I'm driving at 80 kilometers per hour. Okay, but if I'm driving at 120 kilometers, will I take longer or less time? Okay, so that's what we are looking into. You need to reason it out. The faster I'm driving, the less time I'm taking. If I'm driving slow, if this is going down, I'm driving slow, this one increase the time that I take in order to reach the destination increases. So there is this thing going on. One quantity is increasing, the other one is decreasing. So in that case, we have an indirect proportion. Okay. So now, if you are dealing with indirect proportion, let's again write the same thing, formula. Okay. If you look at the formula, so now a journey, time and speed. Let's look at time and speed. We have a time here is going to be indirectly, so we must write the other one under 1. So it must be reciprocal of the speed. Okay, put it under 1. Okay, indirectly proportion. We are using the same proportional symbol. Okay, but 1 is written below the line. It can be this one or that one. It doesn't matter which one you write under the line. Okay, so it's a reciprocal of this quantity. Okay, now again, what we need to do is we must now look for a quantity that will make these two equal to. So that means there must be, okay, excuse me, there must be a constant that will make these two equal. Okay, we can rewrite this. We can say T is equal to K over V. Okay, all right. Now we can plug in what we are already given. At least we are given one. 15 minutes for 80 kilometers per hour. So we can plug it in. Time, 15 minutes, excuse me, equals K over speed is 120 kilometers per hour. Okay? Now, this is in hours, this is in minutes. So we have to do something here. Okay? We have to convert this into hour. 15 minutes is just a quarter. So we can rewrite it as 0.25 hour is equal to K over 120 kilometers per hour. Okay. Now we do the calculations there so that we can find our K. So our K will be equal to, when we do the calculations here, our K is equal to 20. All right? Okay. Once we have our K, we come and plug it back into the formula, because this is our formula. So we plug it in there. So we have T is equal to 20 over V. So we have a formula here that we can make use of. When it comes to speed and time, we can make use of that. Now, if I'm driving at 120 kilometers per hour, what will be? Oh, excuse me, I made a mistake here. This is supposed to be 80. Nobody is correcting me here because I am not in a face-to-face classroom. Okay, that is 80. That's supposed to be 80. Sorry for that. It's not 120, 80, because these are the ones that we are given for 15 minutes when I'm driving at 80 kilometers. Okay. Now I want to find out for 120 kilometers per hour. How long will I take? That is the question. So I just plug it into the formula. Okay. How long will I take? T is what I want to find out. Okay. T is what I want to find out. 20 divided by 120. So I work out this. 1 over 6. It must be in hours. Okay. All right. What is 1/6 of an hour? So it will be equal to 1/6 times 60, because you want to convert it into minutes, which gives us 10 minutes. Okay. All right. So if you drive at 80 kilometers per hour, you are taking 15 minutes. If you drive at 120 kilometers per hour, you are taking 10 minutes. Okay. So that is the direct indirect proportion. Okay. Let's continue. All right. Let's look at equations. In order to use indices, equations, indices, and units. Let's first look at indices. In order to use indices effectively, students need to know the following: the basic rules of indices. Know your basic rules of indices. You need to memorize them if you can, okay? For example, one of the rules of indices is any number to the power of m times a to the power of n. If the bases are the same, what we do is just to add up the indices, or indices. We just add them up. Okay. This whole thing is called the power, and this is the base, and that's the index. Okay. So we just add it up. Okay. So know all the rules. With the units, what will normally happen with the units in an assignment or in exam is that there are certain units, conversion of units that you need to know. Okay? You need to know them. Or you need to work them out yourselves in the exam from the memory. Okay? But when it comes to non-conventional units, what you need to do is you really need to those are going to be given to you in the exams. I'm running out of time here, so I'm just going to fast forward it. Draw and interpret different graphs. Okay, just look at that. You need to know coordinates, make a table, use appropriate scales, and draw graphs. Okay. So you should be able to draw graphs, whether it is straight line graphs or not. Okay. When it comes to circles, the first thing that you need to know, whether it is in the module or not, one of the things that you need to know is you need to know the parts of the circle. If you don't know the parts of the circle, and there is a sentence that says a sector, now how are you going to calculate the part of the circle if you don't know sector, what it means? Okay? So know the parts of the circle. That's the first and the most important thing. Okay? And should be able to calculate the areas of rectangles, areas of circle. Here, what I'm trying to just point to you is that how we have derived the formula for the area of a circle. Okay, you can go and Google or go to YouTube. You will be told how we have come up with the formula of a circle and the formula for the area of a circle and also for the circumference of a circle. Okay, units used to measure angles. So you need to know them. Okay. Radian measure, you also need to know them. Okay. Look into the definitions. The most important thing in mathematics is you need to know your definitions. Okay. Know your definitions. Without definitions, you will not be able to do your calculations. Okay. All right. Similar triangles, also very important. The only thing I will tell you about similar triangles is that similar triangles, the reason why they are important and they comes in mathematics books and so on is because we make use of similar triangles and many other geometrical objects in order to measure things indirectly. Things that we cannot measure directly, we measure them indirectly. There are applications of that here. You can see those applications. Okay? How did we figure out the distance from here to the sun or to the moon and so on? These indirect measurements. Okay? We have measured these things indirectly. Okay? So that's basically what you need to know about similar triangles. Okay? Go through it. Okay? I have given you examples here which are going to be useful for you. You can always call me and I can explain and also give you more information on how to tackle assignments and also how to tackle how to prepare yourselves for the exams. Okay? Assignment instructions. Questions should be answered on the A4 papers. Write neatly and illegibly. Most of these mathematics exams are actually answered on the question paper. Okay? You don't have to worry about it. Okay? All right? Look at those instructions that you need to follow when it comes to assignments and also exams. Okay? So you're working. Know your calculator. All right? That's very important. Okay? All right? Thank you very much. And again, once again, if you do not understand anything in the course, you can contact me and I will be able to really help where I can. Bye-bye.